Thank you very much. Good morning. Welcome to TEDx. About a year ago, I went caving with my youngest son, some of his friends, and their parents. One of the fathers is an experienced spelunker, and he suggested as our first experience we'd go to a cave, a wild cave, near Bowden, West Virginia. He was an excellent guide, but his definition of moderately difficult and my definition of moderate difficult, very different. And as you can imagine, spending a whole day in tight, dark, wet places, I'm not built for that. We had a great time, and as we're hiking along for about 2 kilometers under this giant mountain, we came to the parts of the cave where the entire floor of the cave was an underground river. And we were told, we're going to hike up through the river to get to this real cool chamber. It's 2 stories and it's worth seeing. So we took off our day packs and we started going upstream. And I got about halfway and my headlights started to dim. I said, you guys go ahead. I brought plenty of batteries. I was a Boy Scout after all, but they were back in the pack. So they continued onward. I turned back and my headlight kept dimming. And it dimmed until eventually it was completely and totally dark. And I stood there in the middle of this underground river. I couldn't hear anybody. I couldn't see a thing. And I'd never been in such an inky, dark, black place. And more importantly, I'd never been someplace that was so dark where I couldn't change the illumination. I was in nature. And I stood there for a while. I said, well, I can probably find my way back just stepping slowly in the dark. And I took about 5 or 6 steps before I fell. I broke a finger, actually. And I stood back up and said, this is not good. And finally, as I was standing there thinking, I'll just wait for them to come back, it occurred to me, I didn't want to leave my valuables in the car outside the cave, and so I had put my iPhone in a plastic bag in one of my interior pockets. Thank you, Steve Jobs. And there is an app for this, getting lost in a cave in the dark, and I was able to get back to my pack. But the point is, and let me put up a quote here, that maybe you need to know darkness before you can appreciate light. And I don't want to come off as one of these intellectual professor elite, which are so unpopular among politicians these days. So let me put another quote up there from my favorite comedian, George Carlin, in the role of the hippy-dippy weatherman, which is weather forecast for tonight, dark, continued dark overnight with widely scattered light by morning. Now, unfortunately, for most of us in industrialized societies, that weather report is no longer true. So for the past 130 years, we've been able to illuminate our interior spaces and the night skies. And although 130 years is a long time for a human being, my parents had lights, their parents had lights, my great-grandparents, no. 130 years is just a blink in the 3 to 4 billion years of evolution of life on this planet of light days and dark nights, and all the adaptations that have occurred in response to this very fundamental environmental cue. Just a blink. And so you have to ask ourselves, despite the convenience of having electrical lights, are there any downsides? And I'm going to argue based on some mouse data that yes, there are some downsides in how our circadian rhythms are being disrupted, independent of sleep. Now, I'm no Luddite, thank God for my iPhone, or I'd still be in that cave in West Virginia. Light at night's allowed economic growth. It's allowed unprecedented nighttime activity. You can go to the 7-Eleven and get beer at 3 a.m. That's useful. Light at night's provided security for the first time in our evolutionary history. We don't have to be as scared of the dark. And that's useful if you live in rural Ohio where lions and tigers and bears may be out there. But these city lights leak out. And if you live anywhere in a major city with a beltway, You look up, you can mainly see 100 stars, not thousands and thousands anymore. Just a few. And if you happen to be a bird that migrates by stars, that's not good. And if you like the aesthetics of stars, that's not good. All right? And if you like energy efficiency, probably not so good. It's pretty. In fact, you can see these stars, you can see these lights out in outer space. You can identify cities. There's Columbus, Ohio. And we bring this light into our homes, with televisions and computer screens and electrical lights. And what does that do? What's the harm of all this pretty, useful light? Well, what I'm going to suggest is that's two health phenomenon that have been increasing, and increasing in societies that modernizes and has electrical lights, may be due to this light at night disrupting circadian organization. So as you all know, obesity trends are escalating in this country. In 1991, about 10 to 15% of American adults were obese. In 2007, 20 to 25%. Now it's estimated to be about 30%. And also, depression rates are increasing. I can't read all, that's a terrible slide, I apologize. There. It's going up. Worldwide, 20% of people are clinically depressed, and it's going up, okay? And you may not know this, is that BMI is associated with moderate to severe depression. The higher the BMI, the more likely you are to suffer from depression. Now, what causes this? Well, the most obvious thing we all have come to internalize and believe is that adopting a healthy Western lifestyle is part of this. Lots of calorie-rich foods, that's not me. Lots of calorie-rich foods with very low foraging efforts. It doesn't take much to go to the Kroger and get all that good calories. That's different from our evolutionary history. But what I want to suggest is there might be something else, this will be tricky, the light at night, that may make this epidemic of depression and obesity occur. So if you look at the UK data, you can see that they have the similar trend of obesity in their society, and that's occurring exactly the same time when adults are exercising more, not less, but exercising more in all age groups except, of course, lazy teenagers. Now, any kind of phenotype, whether it's obesity or depression, is an interaction between the genes and the environment. And because this is happening so quickly, I think we can rule out the contribution of genes. It's happening within 1 or 2 generations, and start looking at some of the environmental factors. And what I want to say is that light at night reduces secretion of an important hormone called melatonin from the pineal gland. And light at night disrupts a lot of circadian rhythms in addition. Now, melatonin is a very interesting hormone for a couple of reasons. One, it provides temporal information, transduces temporal information from outside to all the cells in the body. It's secreted only at night in nocturnal and diurnal creatures. So if you have a summer night, a summer-long day, a short night, the relative duration of melatonin is brief, whereas this time of year, the duration of melatonin is extended. Okay? So if you have clock genes in cells in your liver or heart that are cued to the elevation or the decrease, the phase relationship changes seasonally. So every cell knows if there's melatonin, it's nighttime, and if this relationship is far or close, it's a certain time of the year. However, this hormone is exquisitely sensitive to the environmental light. So if you're exposed to light at night, you crash this hormone, and it stays down for the rest of the night. And if you have light at night every night, your hormone levels are always down, and the circadian relationships go away. And how many of us have light at night every night? All of us. Okay, so I'm going to talk about light pollution with energy metabolism and also with mood. So our first study is simple. We put some mice in a room, the light was just left on all day and night. And within 8 weeks, they gained 15% or so of their body mass. That's all that happened. They had light at night. I'll skip that. Bright light's not so great. It does some things to circadian organization, dampens it down. So we gave them dim light at night. And by dim light at night, we define this as 5 lux of light. It's about what a kid's night light is 1 meter from your eye. Not much light. I can't read by it. Maybe some of you youngsters can. But regardless of whether it's bright light or dim light, they gained weight relative to the animals who got dark nights over 8 weeks. Okay, and most of that weight was fat. If you gave them a glucose tolerance test, animals who were exposed to light at night, whether it's dim or bright, had higher levels of glucose relative to animals in the dark. All right? And if you give them a high-fat diet, insulin levels were increased. So we basically recapitulated metabolic syndrome. 8 weeks, dim light at night. Now, what's important is during this experiment, the animals had exactly the same amount of activity. They ate exactly the same number of calories, either on the high-fat or the low-fat diet. So in summary, light at night made them fat. Now, something's wrong here. We've broken some rules of thermodynamics or something. That doesn't make sense. Well, it turns out it's the timing of when the animals ate this food. Okay, so these are nocturnal creatures. We did that on purpose so we wouldn't influence sleep. They eat most of their food during the night. But the animals getting light at night ate at the wrong time. They ate during the day, like snacking at night. So when we did an experiment where we forced animals in light at night to eat during the dark or during the light, animals were forced to have food only during the light gained weight. And animals that were in dim light at night, if they only could eat food during the dark, did not gain the weight. So it looks like this, the timing of when food occurred that was important. Again, no difference in calorie intake, timing only. How are you going to fix this? Big Pharma going to develop a big drug? No, you put them back in a dark night and you get this fix. Let me talk about depression. How do you measure depression in a mouse? Well, we take different parts of it. And what we measure is anhedonia, which is failure to take pleasure in something you took pleasure in before. And what rodents like is to take in sugar. And so we give them 2 bottles, one with sugar solution, one with water solution. And a typical mouse takes great pleasure, we'll say, in drinking this sugar solution. If they have light at night, however, that's reduced. That's their depressive anhedonic response. What's interesting, if you look at the brains of these animals who get light at night for 8 weeks, do you see these little knobs on the processes of these nerve cells? Those go away if the animals are in light at night. The actual structure of the brain changes, and these are important for connections to other brains. And it's related to how many spines there are to how much depressin there are. It's not a stress response, and you can fix it. We can fix it after just 1 week. I'm sorry, after just 2 weeks here of dark skies. Here's a response of inflammatory marker. Inflammation is bad. It's associated with depression. It goes up in dim light. Again, we can fix it, putting them back in the dark. We can fix the structural changes in the spine density simply in 1 week, getting them a dark sky. So all this is reversible. And now we want to move this to people. But it's hard to get people to go through these kinds of studies. But some of our neighbors have already engaged in a study, and that's, of course, our neighbors, the Amish, who do not expose themselves to light at night, do not have TVs or computers or things like that. And if you look at their health, they have much less cancer than we do. They have very little depression, not 20%, less than 1%. Zero obesity, 9% in the women, 0% in the men. They exercise a lot, but they take a lot of calories in, and they don't get type 2 diabetes to the extent that we do. And so we're studying their light exposure, their diets, their exercise, and trying to sort out what's driving some of this. Also looking at our vulnerable populations in the hospital. People who are in long-term care basically live in constant light. They never go outside, they get dim light at night. And folks in the cardiac and in the medical intensive care, when we look, the folks at night are getting lots of light at night. And so we're trying to figure out a way to reduce that. And we did a mouse study of cardiac arrest, and what we found, which is stunning, is that if the animals have cardiac arrest and then are resuscitated, we put them in a mock cardiac intensive care. If they have dim light at night, just 7 days, only about 50% of them survive, whereas about 85% survive if they have dark nights. And if you look at the brain damage, this is a stain called floral jade. So if you see jade color, that means there's brain cells dying. And you can see the animals exposed to light at night, lots of cell death compared to the animals with dark skin. Lots of upregulation of inflammation, these bars here. If we block those inflammatory signals, we can get survival up to 100%, all right? Or we can turn off the lights. All right, so the bright idea, not so bright at all. Turn off the lights. It's TED Talk, technology, I'm very low tech. Let's use sleep masks, let's use blackout curtains, let's use these kinds of goggles which block out the blue wavelengths that suppress melatonin, which all the new compact bulbs, unfortunately, are blue light. And let's do the low-tech things that we can do to improve health and medical outcomes. So, got this fortune cookie the other day. May you have light during your darkest hours. Let me wish you something else. Let me wish you darkness during your darkest hours. Thank you.